Please support me through PayPal to devinrhythm@gmail.com. devinrhythm@gmail.com is one word, all lowercase. If you're interested in tutoring in person or online, you can contact me at that same email. I'll put this information in the comments. Please subscribe to my channel. I want to talk about my mnemonic for memorizing the sum and difference identities for sine and cosine. So I'll begin by just saying the identities. The sine of a plus b is equal to sine a cosine b plus cosine a sine b. The sine of a minus b is equal to sine a cosine b minus sine a cosine b. The cosine of a plus b is equal to cosine a cosine b minus sine a sine b. The cosine of a minus b is equal to cosine a cosine b plus sine a sine b. Alright, my mnemonic is that I think of sine as the good son and cosine as the bad son, his bad brother. And this characterization of sine is good and cosine is bad works not just for these identities, but it seems to pervade a lot of math. And maybe, I'm not sure quite why, but maybe the reason has to do with the fact that if you consider their graphs, sine seems to just behave more or less like an identity function, because visualize the graph of sine, y equals sine x, in your head, and then visualize the graph of y equals x. They both look pretty much the same around the origin, in fact, because they both pass through the origin, and their slopes are both positive, right? That just seems like a natural thing, like to have a positive slope. Also, at the origin, another piece of evidence that they're sort of the same graph by the origin is that the limit of sine x over x as x approaches 0 is 1. Cosine, on the other hand, doesn't look like an identity function. I mean, it starts out at a peak, right? It starts above the origin, or at the origin, its y-coordinate is 1 instead of 0. All right, so let's take the first of those identities. The sine of a plus b is equal to sine a cosine b plus cosine a sine b. All right, my little scenario is it's sine's birthday, and he gets two presents, a and b. And being the good son, he's not selfish. He lets his brother cosine play with his gifts equitably. So during the first hour after his birthday, sine plays with toy A, and his brother cosine gets to play with toy B. And then when they get bored with playing with their respective toys, they switch. So the second hour, so plus, sine plays with toy B and cosine plays with toy A. The cool thing, and remember I said this thing about sine being the good son seems to pervade all of math. It's pretty cool because sine being a good son pervades this first identity in two dimensions. First of all, he's kind to his brother by sharing his toys, but the second way it pervades it is for the reader or the learner of the identities, the plus sign or the sign is unchanged. We have a plus sign to the left, sign of a plus b, and then a plus sign on the right side of the identity. Right, now let's go to the second identity. So again, sine is sharing his toys. We have the sign of a minus b is equal to the sine of a cosine b minus the cosine of a sine b. And so sine is nice because he's letting his brother play with his toys. And he's also nice because for the reader or the learner, he's keeping the same sign, no pun intended. So we have a minus sign on the left side and a minus sign on the right side. Okay, let's do the cosine ones. The cosine of a plus b is equal to cosine a cosine b minus sine a sine b. All right, cosine being bad and selfish, he hogs up. So now it's cosine's birthday. He gets two gifts, a and b, and since he's selfish, he hogs up the toys and plays with both of them during the first hour. He doesn't let his brother sine play. So cosine plays with a, cosine plays with b, cosine a, cosine b. And then he gets bored with them after an hour and just leaves and says, okay, sine, you can play with these. So then sine plays with them. So then it's plus sine A sine B. Cosine also being perverse changes the sign on the learner to make it hard. The sign meaning plus or minus. So on the left we have the plus sign, but on the right side we have the minus sign. So the fourth identity, I think you get the pattern now. The fourth identity, cosine is still selfish with his toys, and then he swaps up the sign on the reader. So the left side has a minus sign and the right side has a plus sign. All right, I just wanted to illustrate maybe some more about, I said in other areas of math, sine is nice and cosine is bad. Let's take derivatives. What's the derivative of sine? The derivative of sine is cosine. So just being nice, just handing it off to his brother. What's the derivative of cosine? Negative sine. Again, being a little perverse to the learner, he has to swap up the sign. It goes from plus to minus. The derivative of cosine is minus sine. And this perversion seems not just particular to cosine, but it seems to have to do with anything that begins with any trig function that begins with co. So those would be not only cosine but cotangent and cosecant. Because if you notice the derivatives of cotangent and cosecant, they swap the sign on the reader, plus to minus, minus to plus. So what a little other sort of related mnemonic that's helped me in calculus is if the father has a there's a sign change. All right, for derivatives, I think of father and son. Derived means derived from, like fudge is a derivative of chocolate, it comes from. So I think of the so-called original function as the father and the derivative, the son. So, so we can sort of go both ways, from a function to its derivative, or that's going from father to son. If we start with a function and integrate it, or take the antiderivative, that's going from son to father. So to know whether we need to change any signs involved, like plus to minus, minus to plus, there's this little mnemonic to find. If the father has a in other words, if the father function is cosine, cosecant, or cotangent, there's going to be a sign change involved. All right. So I'll conclude this video in a bit. I just wanted to go through my usual shtick of understanding being more important than memorizing. So to illustrate that, today what we did is it's in the memorizing sort of family. I didn't really, although I guess I'm trying to show you my philosophy of math. I try to incorporate understanding. I think I'm illustrating my mnemonics are sort of full of understanding. It's a whole system of mnemonics, and it is related to what's going on, I think, a bit, because I tried to show how the sine function is more like an identity function. I bet that's sort of the key of like the sine being a nice boy. And my identity is sort of melding into understanding, because it's sort of a whole system with, if the father has a there's a sign change. And I got 4 out of 4 of those sum and difference identities with one mnemonic. But it's still memorizing. I think it's a great mnemonic, but it's still memorizing. When I say understanding in math, I don't mean, do you understand what it means that sine of A plus B equals sine A cosine B plus cosine B sine A? In other words, you understand that A and B stand for angles, and that you're taking a sum, and that you don't have the division of sine. I'm saying, if you understand that identity, do you know why that identity is true? Have you proved it, or have you derived it, or have you convinced yourself that it's true? That is the key, I believe, to true progress in math and physics and creativity. Because, if you understand what's these proofs are hard. I proved those 4 identities. I'd like to do a series of videos on them, or at least one, and they were, I think, the hardest proofs I've ever seen or done. But it was good practice. It made me a better mathematician. I encourage you to try those proofs. Try to prove the 4 of them, those sum and difference ones. I guess I could give a little hint. You only have to prove the sum ones, because, right, the difference ones can just easily be derived from the sum identities. So we just have 2 to prove, right? The sine of A plus B one and the cosine of A plus B one. And my proof relies on like the unit circle. I'm visualizing the unit circle, or maybe I should, sometimes I switch in my mind between a unit circle and just a circle, because sometimes for trigonometry or pre-calculus, I don't want that radius to be 1. I think you see what I mean. Okay, I'm going to stop this video now. Bye.